So direction cosines and direction ratios. We have to see the direction cosines and direction ratios. So for this, again, we have seen, suppose we have given this 3D cuboid. Okay. Now, this is representing this line. Both this line is x-axis, so this is representing x-axis. Okay, and this one is representing y-axis, and this one is representing z-axis. You understood? So this is x-axis, and this one y-axis, and this one is your z. The 3D diagram. Then you have this is this point here. You have a point on this corner which is denoted by P. So its coordinates are suppose x, y, and z. So when you join, this is the origin and its position vector. What will be its position vector from O to point P? Join O to point P is the position vector of this point. Okay, got it? Now this line, OP line, is making some angle with x-axis, y-axis, and z-axis. So suppose this line is making with x-axis in the positive direction of x-axis, alpha, beta, and gamma. Suppose this with x-axis, this line is making with x-axis angle alpha. Okay, and with y-axis, this line is making with y-axis positive direction of y-axis beta, beta, and with z-axis is making gamma. Okay, so alpha, what are alpha, beta, gamma? Alpha, beta, gamma are called the direction angles. Here alpha, beta, and gamma are direction angles. Angles, because these are the angles, direction angles. Okay, they are called direction angles. And the cosine values of these angles is cos alpha, cos beta, cos gamma. They are called direction cosine. That's why it is called direction cosines. So cos alpha, cos of the angle which the line makes with x-axis, cos of the angle which the line makes in the positive direction with y-axis, and cos of the angle which the line makes with z-axis. This cos alpha, cos beta, cos gamma, they are called direction cosines. So for direction cosine, we are using short form DCs. Direction cosines. So are called DCs. So these are called direction cosines. And they are denoted by L, M, and N. They are denoted by always denoted by L, M, and N. So that is, we can say that L is equal to direction cosine, L is equal to cos alpha. L is always cos alpha, and M is always cos beta. This is the standard notation, cos beta, and N is equal to always cos gamma. So cos alpha, cos beta, cos gamma. Okay. Now there is one relation between L, M, and N. There is one relation between L and M. Direction cosines has one relation between them, that their sum of the squares, L square plus M square plus N square, is always equal to 1. So what do you infer from this one? L square plus M square plus M square is equal to 1 means, if you can you take any three numbers whose square is equal to 1, three not fractional numbers, three real numbers, not real numbers, any three natural numbers. So it is not possible. From 1 to 100 you cannot get. So this shows that these three, either two of them will be 0, two of them will be 0, one condition, and one can be 1. If L is 1, then M and N will be 0 if 1. Otherwise, all these three will be in fraction only. So the fraction, square of the fraction can be equal to 1 only. Otherwise, it is not possible. Okay. So what are the direction cosines of x-axis? So direction cosines of x-axis. X-axis means when this point will come on x-axis. So cos 0 degree. Cos 0 degree is 1. You know that. When, what are the DCs of x-axis? We want to write the DCs of x-axis. What are the DCs of x-axis? Therefore, x-axis means the point P will come on x-axis somewhere here. Okay, when the point P will come here, that line will make with x-axis 0 degree, and cos 0 degree is 1. So L is equal to 1. And with other angles, with other, this line, when the line OP will become x-axis, then this line will make 90 degree with y and z axis. So cos beta, beta is 90, alpha is 90. So for direction cosines, alpha is equal to become 0 degree for x-axis if the P point comes on x-axis, and beta will become 90 degree, and gamma will also become 90 degree. Okay. So that means the direction cosines L will be equal to cos 0 degree. L is equal to what? Cos 0 degree, and cos 0 degree is 1, and beta will be equal to cos 90 degree, and cos 90 degree is equal to 0, and gamma is equal to also cos 90 degrees, that is equal to 0 also. So direction cosines of x-axis are 1, 0, and 0. 1, 0, and 0. That means if you will add, you can check 1 square plus 0 square plus 0 square is equal to 1. So always their sum will be equal to 1. This is the best way to check the direction, whether this is direction cosines or direction ratios. We'll come to direction ratios also. This is the best way of checking it. Okay. So you can see there. So similarly, if now you can say, no need to explain for y and z axis, what will be the DCs of y axis and z axis? So DCs of y axis, DCs of y axis क्या हो जाएंगे? DCs of y axis will be 1, 0, 0. Okay, DCs of y axis 1, 0. Similarly, DCs of z axis, direction cosines of z axis will be equal to 0, 0, and 1. And why, I think you understood why it is like this. Okay. Now, one more thing is there, that is called direction ratio. What are direction ratios? You have seen that x, y, and z. So if you draw a triangle, suppose this is with y-axis, if you are drawing triangle, or you are drawing yes, for y-axis, yes, sorry. So for y-axis, uh, this will be correct. For y-axis, y coordinate will be equal to 1. Simple. Y-axis, y coordinate will be equal to 1. For x-axis, x coordinate will be equal to 1. For z-axis, z coordinate will be equal to 1. So with this angle, if you draw a perpendicular, suppose I'll tell you 1 minute. Let me take another color so that you can understand better. Okay. Suppose, just see this. OP is a point in 3D diagram. From OP, if I draw a perpendicular on from this point, perpendicular from this point. This is the perpendicular. Okay. It is looking like this, but it is a perpendicular, because it is in 3D diagram. So then what will be cos alpha? What will be the value of cos alpha here? Okay. So OP is R. What is OP? I told you in the previous video, I told you that OP is a vector which is denoted by vector R. Okay. So cos alpha will be equal to, and this is x coordinate, means this length will be x axis. On x axis, the length will be x. Suppose this is x, or if you are drawing at any point here also, you can see perpendicular on this point. Should take this point because we have taken this x. But okay, no problem. So now what will be the value of cos alpha? So cos of alpha, cos alpha will be equal to base upon hypotenuse. Cos alpha will be equal to x upon r. Okay, got it? Base upon hypotenuse. This is perpendicular. This hope this point I can take A. This A. AP is perpendicular and OP is hypotenuse. This triangle. This looks like bigger, but because of 3 diagram, this is bigger. So 3D in 3D, just imagine this is 3D, then you can understand better. So cos alpha will be equal to x upon r. Similarly, cos beta will be equal to y upon r. R is what? R is the magnitude. Either you write in terms of magnitude, or this can be written as r. R, if you are writing only r means the magnitude of the r. So either you write like this or only r. This will represent the magnitude. Okay. So remember this. So here we are using the magnitude. But left side is also magnitude. We cannot equate vector to the to the scalar. So both are scalar. So cos alpha, cos beta, and cos gamma. Cos gamma is also equal to z by r. From this, we got x is equal to r cos theta, y is equal to r cos alpha, y is equal to r cos beta, and z is equal to r cos gamma. So point P, now we can say that the point P can be denoted by their coordinates R, x is equal to R, cos alpha, y is equal to R, cos beta, and z is equal to R, cos gamma. Or cos alpha is what? Cos alpha is also equal to L, and cos beta is equal to M, and cos gamma is equal to N. So if you replace element, so x is equal to L, R, or you can say that the coordinates of point P can also be represented by LR, MR, and NR. These LR, MR, NR are proportional to direction cosines. LR is proportional to direction cosines. MR is also proportional to direction cosine. Hmm? LR, MR, and NR are proportional to direction cosines. Hmm. These are called the direction ratio. So the number, these numbers, so now you can say that numbers, these numbers, what are these numbers? LR, MR, NR numbers are called LR, MR, NR are proportional to direction cosines. Are proportional to direction cosines. Proportional to direction cosines and called direction ratios. These numbers are called direction ratios. Direction ratios. And similarly, the direction ratios are, we are denoting direction ratio for our country. Also, DRs. So these are the direction ratios. So direction ratios are nothing but they are the numbers which are proportional to direction cosines. Okay. Now I will give you one, two, three more points. We have 9 minutes left. Then you can understand easily. There are points you have to remember to find out whether the given. This is the best way. I told you this is the best way to remember. But there are some points. By this way, if any vector is given, you can check if it is equal to, then they are direction cosines. If not given, otherwise direction ratio. So take the screenshot. Now some more information about direction cosines and direction are required. Okay, maybe I need this diagram. Okay, no problem. Now we have seen L is equal to x upon r, and so what is x, y, and z? We have seen that what is x, y, and z. Again, see this one. Vector r is represented by xi plus yj plus zk. Okay, this is the vector, and in any vector, always you will find that x square plus y square plus z square is not equal to 1. But in general, but you will find there L square plus m square plus n square is always equal to 1. Why? Because L is equal to, we have seen L is equal to what? X upon r, and y, m is equal to y upon r, and n is equal to z upon r. When you add them, L square plus m square, L square plus m square plus n square. So finally you will get x square upon r square. So you can take the LCM, x square plus y square plus z square upon r square. And I told you magnitude, we can write r is a magnitude. This is r, or r is equal to root. So therefore r square will be equal to x square plus y square plus z square. This can be, so we can replace this by r square. So r square upon r square is always equal to 1. So if you have given, what will be these values? If suppose you have given next condition, okay, you can put number 1. Second condition, if a vector A is resolved into the components A1, A1i plus A2j plus A3k, then A, B, C are also called direction ratios of vector A. These are called the direction. Then A1, E1, A1, A2, A1, A2, and A3 are also also called direction ratios of, are also called ratios of vector A, of vector A. Okay. So I think you understood now how to find the direction cosine direction ratios. So maybe 3 minutes left. I'm writing one question. You will not get. You can discuss in the next class, but try. Find a vector. Then is find a vector A of magnitude 5 root, vector A of magnitude 5 root 2, making an angle of 5 by 4. pi by 4 with x-axis, the pi by 2 with y-axis, and an acute angle theta, acute theta with z-axis, z-axis. Here to find this vector A. Okay. So here alpha, beta, gamma is given, cos alpha, cos beta, only cos gamma is not given. So you have to find the angle gamma. Gamma is theta here. And vector A is given. Its magnitude is given, vector A. Okay. So try this question. Okay, take the screenshot. Trying to be within 1 minute. So take the screenshot. Take your WhatsApp group for the PDF and for the videos.